Hello, this is Mr. Rose, and this is part two of lesson 4.2. We have six more examples that we would like to go over just to give you plenty of examples to look at when you do your assignment. Remember, we're solving right triangles, and the first thing you want to do when you solve a right triangle is write down all six parts of the triangle. So on this first example here, number 7, we have the measure of angle U, the measure of angle M, and the measure of angle E. We also have three sides here. We have UM, we have ME, and we have EU. Okay, let's continue on this by writing down the measurements that we do know. We know the angle EM is a 90-degree angle. We know that EM or ME is 19, and we know that EU is 28. Now, in order to find some missing pieces here, we're going to have to use some inverse trig functions, the Pythagorean theorem, subtraction. We've got several tools in our toolbox. And right now I see that I have two of the three sides of a right triangle, so that tells me I can use the Pythagorean theorem to find side UM. Now UM is one of the legs, so let's write UM squared plus the other leg squared would be 19 squared equals the hypotenuse squared, that would be 28 squared. You want to evaluate your powers now. 19 squared is 361. 28 squared is 784. You want to subtract 361 from both sides, and that's going to give you 423. The next step is to take the square root of both sides, and when you do that, UM comes out to be approximately 20.6. For right now on this lesson, we're just going to go ahead and write the decimal form of the answer, round off to one place after the decimal. So UM is 20.6. That gives me my third side of the triangle. Now, as far as the missing angles are concerned, I've only got one angle here. That's the 90-degree angle. So I'm going to have to use some inverse trig functions in order to find the missing angles. In regards to angle U, the opposite side is 19, and the hypotenuse is 28. Now, if I use SOHCAHTOA, opposite and hypotenuse have to do with the sine function. So the sine of angle U is equal to the opposite, which is 19, over the hypotenuse, which is 28. And you want to do the inverse sine of both sides to get the U by itself. Remember, you probably have to put parentheses around the fraction there. And when you use a calculator to evaluate that, angle U comes out to be approximately 42.7 degrees. Now to find angle E. Angle E is this angle. Now this 19 side EM or ME is now the adjacent side, not the opposite side. Remember, the hypotenuse is always the hypotenuse. So if I'm dealing with the adjacent side and the hypotenuse, I'm dealing with the cosine function. So the cosine of angle E is equal to the adjacent side, which is 19, over the hypotenuse, which is 28. We want to do the inverse of cosine to get E by itself. And when you use a calculator to evaluate that, E comes out to be 47.3 degrees. Now we have all 6 pieces of the triangle and it is solved. I do want to remind you that you should not use found measurements in your calculations. In other words, once you find a measurement, write it down, but don't use that measurement to find other measurements, because if you've made a mistake, then you're going to end up making another mistake when you use that in a calculation to get something else. So always use your original measurements. All right, let's look at example number 8. All right, we have some angles and sides missing again, so we want to write all those down. Let's write that up here. We've got the measure. Whoops, scoot that over a little bit. Okay, we've got the measure of angle A, the measure of angle R, the measure of angle T, and we have side AR, we have side RT, and we have side TA. Now, as always, we want to write down what we already know. We know that angle R is a 90-degree angle. We know that angle A is a 24-degree angle. We know that side AR is 33. Now we have to find an angle on 2 sides. Now, as far as the angle is concerned, I realize that I've got 2 of my 3 angles. On a right triangle, one of the angles is always 90, so if I subtract that from 180, I get 90 left over. That means that the 2 acute angles have to add up to 90. So if I want to find the measurement of angle T, all I have to do is take 90 minus angle A, and when I do that, I end up with 66 degrees. Now, in terms of the angle that I know, angle A here, side TR is my opposite side, and side AR is my adjacent side. So if I'm doing SOHCAHTOA, opposite and adjacent have to do with the tangent function. So I'm going to have to use tangent in order to find those measurements. So the tangent of 24 degrees is equal to the opposite side, which is TR or RT, over the adjacent side, which is 33. All right, now, in order to get the RT by itself, I want to multiply both sides by 33. And when I work that out on a calculator, I end up with RT being equal to 14.7. Now to find TA in regards to the 24-degree angle, my angle A, that's the hypotenuse. And if I'm using hypotenuse and the side that I know is the adjacent side, that means I'm going to have to use cosine for my function. So the cosine of 24 degrees is equal to the adjacent, which is 33, over the hypotenuse, which is side TA. Now remember, this is one of those where we've got our variable on the bottom, so we can do the flip-flop procedure. So I'm going to take TA is equal to 33 over the cosine 24 degrees. And when I do that on the calculator, TA comes out to be 36.1. Now remember, if you're not getting these answers that I'm getting when you use the calculator has to be set on degree mode. So there's usually a button on there that says DRG, and you have to click that so that it's on D for degree. You're measuring your angles in degrees in these problems. So don't forget to do that if you're having problems with getting the answers. All right, let's move on to example number 9. On example number 9, we have our 6 pieces. We have the measure of angle V. We have the measure of angle M and the measure of angle D. And we have side VM. We have side MD. And we have side DV. If we write in what we know that side VM is 14. We know that angle M is 90 degrees. And we know that angle D is 51 degrees. So right off the bat, I see that I've got 2 of my 3 angles. We already know we've got a 90-degree angle, so if I take that from 180, that leaves 90 left over for the other 2 angles. So if I want to find the measure of angle V, I want to take 90 minus 51, and that ends up being 39 degrees. Now, if I want to find the missing sides, I have to look at this 51-degree angle here. And in terms of that 51-degree angle, side VM is my opposite side, and side MD is my adjacent side. So if I do SOHCAHTOA, opposite and adjacent is tangent. So I'm going to use the tangent there. Tangent of 51 degrees is equal to the opposite side, which is 14, over the adjacent side, which is MD. This is another case where we've got the variable on the bottom, so we want to do the flip-flop procedure. So MD is equal to 14 over the tangent of 51 degrees. And when I work that out on the calculator, MD comes out to be 11.3. Now, as far as DV is concerned, DV is the hypotenuse of the triangle, and I know the opposite side, so opposite and hypotenuse is sine. So let's use the sine function for that. So the sine of 51 degrees is equal to the opposite side, which is 14, over the hypotenuse, which is side DV. We can do the flip-flop procedure on this again. So DV is equal to 14 over the sine of 51 degrees. And when I work that out on my calculator, I end up with DV being 18.0. So let's put that in our chart up here, and we have all 6 pieces of the triangle. All right, let's move on to the last 3 examples. Same thing, we're still solving for a right triangle here, and we want to start off by writing our pieces in here. So we've got the measure of angle A, the measure of angle B, and the measure of angle C. And we have side AB, we have side BC, and we have side CA. If we write in our measurements that we know that angle A is 26 degrees. We know the angle B is 90 degrees. And we know that side CA is 4.5. All right, I can see right now that I know one of my two acute angles that I have to add up to 90. So if I want to find the measure of angle C, all I have to do is take 90 minus the other acute angle, 26 degrees, and that's going to end up giving me 64 degrees. Now, in terms of that angle A, the 26-degree angle, BC is the opposite side, and AB is the adjacent side, and AC is the hypotenuse. So let's go back to our SOHCAHTOA. If I want to find side AB, I'm using the adjacent, and I know the hypotenuse. The adjacent and the hypotenuse refer back to the cosine function. So the cosine of 26 degrees is equal to the adjacent side, that's AB, over the hypotenuse, which is 4.5. In order to solve this, what I want to do is multiply both sides by 4.5. And when I work that out, I end up getting 4.0 for side AB. Now, in order to get side BC, I'm going to use the opposite side and the hypotenuse. Remember, don't use measurements that you found in the problem. Use the measurements that they gave you in the original problem. So I'm looking for the opposite side. I know the hypotenuse. Opposite and hypotenuse is sine. So I've got the sine of 26 degrees is equal to the opposite side, which is BC, over the hypotenuse, which is 4.5. And just like before, I want to multiply both sides by 4.5. And when I do, BC comes out to be 2.0. All right, on number 11, if we write out our pieces here, we've got the measure of angle V, the measure of angle W, and the measure of angle X. We also have side VW and side WX and side XV. All right, we know that angle W is a 90-degree angle. We know the X is a 20-degree angle. We know that side XV is 12. All right, I know one of my two acute angles, so all I have to do is simply subtract from 90 to find angle V. So 90 minus 20 equals 70. So angle V is 70 degrees. Now, in terms of the angle that they gave me, the 20-degree angle here at X, side VW is the opposite side. Side XV is the hypotenuse, and side WX is the adjacent side. So if I want to find side VW, VW is the opposite side, and I know the hypotenuse. So I'm going to use sine to find that. So the sine of 20 degrees is equal to the opposite side, which is VW, over the hypotenuse, which is 12. Just like on that last problem, all I really need to do here is multiply both sides by 12. And when I multiply 12 times the sine of 20, I get 4.1 for VW. All right, now to find WX. WX is my adjacent side, and I know the hypotenuse, adjacent hypotenuse is cosine. So the cosine of 20 degrees is equal to the adjacent side, which is my WX, over the hypotenuse, which is 12. Multiply by 12 on both sides, and 12 times the cosine of 20 degrees is 11.3. All right, the last one here, that's really a J right there. I kind of covered it up with my writing. Let's go ahead and write our pieces in. We've got the measure of angle J, and the measure of angle K, and the measure of angle L. And we've got side JK, side KL, and side LJ. As far as what I know angle K is a 90-degree angle. I know the angle L is 31.6 degrees. And I know that side JK is 7. I know one of the two acute angles, so what I can do is just subtract to find the measure of angle J. That's 90 minus 31.6, which is equal to 58.4. All right, in order to find KL, I have to use the angle that they gave me here at L. And in regards to that angle, JK is the opposite side, and KL is the adjacent side, and LJ is the hypotenuse. Okay, so let's go ahead and write our SOHCAHTOA up here. If I want to find side KL, KL is this side right here, and it is the adjacent side. The side that I know is the opposite side. So adjacent and opposite refer back to tangent. So the tangent of 31.6 degrees is equal to the opposite side, which is 7, over the adjacent side, which is KL. This is one of those situations where we want to use the flip-flop method. So KL is equal to 7 over the tangent of 31.6 degrees. And when you work that out on your calculator, KL comes out to be 11.4. Now to find LJ, LJ is our hypotenuse. And I know the opposite and hypotenuse is sine. So we're going to use sine there. So the sine of 31.6 degrees is equal to the opposite, which is 7, over the hypotenuse, which is LJ. Just like before, I want to use the flip-flop method here. So LJ is equal to 7 over the sine of 31.6 degrees. And LJ comes out to be 13.4. All right, so I hope that you filled out your note sheet. Don't forget to submit that for a grade. And I hope that you'll use your note sheet to help you do the assignment that goes along with this lesson. Thank you.